So I'm going to start you off with a template I've been developing to make the process of developing a cross-platform iOS and Mac game a lot easier. So this is already set up as a cross-platform project. So the first thing I recommend doing is just testing out that both schemes for Mac and also iOS will run. So just go through both of those, hit build, and just make sure that the Swift Gamer logo comes up. If you're seeing this, then it is working. So just to give you a walkthrough, this scene here called the Introducer is just a simple scene that I use to preload any assets and just display my logo. So you can modify this to put in your own logo, or put in text, or even just show a blank screen until everything's preloaded. So as you look down here, you'll see a few instance variables. Then in my did move to view, I first set the background color to black. I set up a few animations. I'll show you how these animations work soon. Down here in the function called Start Loading Assets, this is where I preload any textures or sounds, because your textures and sounds will often be the thing that takes the longest to load in the game. It's a lot better to preload your assets rather than have the game pause for half a second while it loads in a texture or an animation. If we have a look now at the view controller for this one, you'll see it's a little different to the view controller code we used previously. This is because I have a lot of presets in here, and this will hopefully make it a little easier to navigate this area. The way it's currently set up, you shouldn't really need to come into the iOS controller or the OS X controller at all. So you're probably wondering where these preset options come from. It's from what's called a property list. If you haven't used a property list before, or plist, they're XML files which can be read and displayed in this database-ish sort of layout. The key is pretty much your lookup value. So if you're trying to find if show frame rate is enabled or not, you would look it up by its key, which in this case is all-show frame rate. Now you'll see the way that all of these are prefixed. It'll be all, meaning it affects both iOS and Mac, or it'll be iOS or OS X. So you can see that there's two sections here, debugging and defaults. Debugging will affect the debug options for the screen, so whether it's showing the frame rate, the node count, or on iOS you have a few extra options such as showing physics. And we'll be having a look at how the show physics option works in a later lesson. Now you'll see when I run this for Mac, it runs in Windows mode. If I change this default for start full screen, when the application launches, it will now be in full screen. There are some other settings for the resolution. This is if you want to make your own resolution picker, which you may want to do if you're making a game with very detailed graphics. So as you saw in the introducer before, it had some SK actions. If I change this introduce value, you can see what those do. Okay, so if we come up in these debugging options, I'll just flip a few of these on and off just to show you how it affects the scene. Okay, now I just wanted to run you through this folder structure. I've set it up how I like it at the moment, but you can really set this up however you want. So I have folders for font, content, music, sounds, and artwork. And you'll notice in this artwork folder, I have put a texture atlas. Texture atlases are made just by taking a normal folder somewhere on your Mac and putting .atlas at the end. It will still function exactly like a folder, but when you bring it into Xcode, it will become a texture atlas. So what does a texture atlas do? Well, to conserve memory, a lot of games use sprite sheets. What this means is multiple images or sprites are joined together in one large image which is loaded in memory, and then it is sliced up and used for animation or just displaying images on the screen at runtime. So a texture atlas allows you to keep all of your sprites as separate images so that they're easy to work with, and then at runtime when you run the application, it will then compile them into sprite sheets. So that is what a texture atlas is. Okay, so coming down here into SG Engine, these are classes that I've made to help you write your game and take some of the burden off of you. So you can add to these or modify these over time as well to bring in functions that you might want to use. To give you an example of one thing that I've done in here, you'll remember from a previous lesson when we talked about the touches began, touches moved, touches ended, etc. and also the mouse down, mouse up, etc. What I've done is I've handled them in this SG scene. So because this is a subclass of SK scene, it means if you make your scenes a subclass of SG scene, that they will then inherit all of this functionality. So you can see down here I've overridden the touches began, touches moved, and also the mouse event ones as well. What this means is that when a subclass of this class is run, when a mouse or touch event happens, it will call this function here, the screen interaction started, screen interaction moved, screen interaction ended. So as long as you have this screen interaction function in your scenes, they will inherit this functionality. So as an effect, you only need to worry about one set of functions rather than multiple ones cross-platform. It just makes it a little bit easier. If that sounds a little confusing, you'll get to use this soon and they'll help you understand the process. The SG Extensions class. So extensions add extra functionality to other classes. So an extension for SK Node then adds other functions or properties to SK Node. The ones that I've added here are to help you position nodes. So you can see that there's position by screen and position by canvas. So screen is the visible area of the screen. So positioning something at 0, 0 will be at the bottom left hand corner of the screen. Positioning via canvas will be based on the scene boundary, which means if you're trying to run a scene that is sized for an iPad on an iPhone, that your position 0, 0 might be off screen. You'll find that there are particular use cases for both of these as we work through this process. So the X and Y values here are percentages of the total screen, and this is between 0 and 1. So if you were to have position 0.5 and 0.5, they'll be in the middle of the screen, or the middle of the canvas. In SG size, I've added some functions to help with this as well, and same with CG point. So SG resolution, this is again to help with those screen coordinates. You won't need to worry about the contents of this class. It only really talks to the iOS controller and the OS X controller. So you can see down here that when the scene is loaded, a SG resolution is initialized and that will then store the screen bounds. SG Game Kit, this contains some basic functionality for authenticating Game Center and posting achievements and scores. Down here I've included SKT utilities. This is made by the Ray Wenderlich team. It really adds some fantastic functionality to the existing frameworks. You'll see that most of these are extensions, so they all add to the existing SpriteKit framework. If you want to learn more about what this can do, it's best to go to the GitHub page. This is also where you can grab the latest version of it. So this will continue to be updated as changes happen with Xcode. Okay, now the only other class I have in here is SG Asset Manager. I'm just using this class to store game textures, game sounds, and game settings, as you can see by these global variables at the top here. And inside this class, I just have a few basic functions to load and close the settings. And that's it for that template. Now if you're having any problems with your template, please send me a message as soon as possible so that I can help you out and make sure that you're up and running with the template before continuing this course.